Okay, let's assume we have a question like this. Given two relations, we have bars. The bar has two attributes, name and address. Name is the key, right? And we also have a sales as another relation. In the sales table, we have three attributes, bar, bill, and price. And the question we have is to find the names of all the bars that are either on Tennessee Street or sell bought for less than $3. So you can try to do this query by writing the answer on your paper. You can pause the video here and write down the answer first. Okay, I hope you have the answer on your paper already, right? And let's do this question together. So given two relations, we want to find all the names of bars that are either on Tennessee Street or sold bought for less than $3. Generally, when you're doing the query like this, you need to analyze what will be the target we want to get. We want to get the names of all the bars, right? And what are the conditions? The conditions are the bars that are either on Tennessee Street. Tennessee Street is the address, right? In other words, the bar on the Tennessee Street, or the bars which sell the bought for less than $3. The bars sell the beer for less than $3, right? The beer name should be bought, the price should be less than $3. Then the question should be very clear, right? And we can analyze this query in a hierarchical way. So we can represent the expression of the query in three ways we showed before, either as a sequence of diamonds, or as a expression with multiple operators, or as an expression tree. Let's try the first one here. We can do a sequence of assignments. Right, we can get the first part here. We want to get the bars on Tennessee Street, right? How can I do this? Let me use a larger font for you. We can use 40. So we can try the first expression. It will be helpful for you to understand or analyze this query, right? We can get the bars on the Tennessee Street first. How can we do this? It should be working on the bars, this relation, right? We want to do the select, right? Let me borrow the select operation we use here. So we can denote this expression by using this we are working on the bars, right? Bars. And what are the conditions? The condition should be bars dot addr, right? Address equals to is a string, right? Equals to Tennessee Street. Right. These are bars on Tennessee Street. What will be the second step? Because we want to get the names of all the bars that are on the Tennessee Street, right? So we can get on the Tennessee Street, right? It will be what? It can be represented as, let's assume we can assign a temporary relation name, like the S1, right? And then we can have S2 equals to what? Equal to the select, equal to the projection, right? We want to project the names of the bars. Then we can borrow the pi we use here, right? And we're working on this S1, right? We project what? We project the names. Right? This will be the name of bars on Tennessee Street. This is the first part, right? And we have either or here, right? Then the second one will be how can we find the bars which sell the bought for less than $3, right? So the second step, the third step will be get the bars, cell, bar for less than $3, right? How can we represent it? We can represent it as a S3, right? Equals to what? Here we need to do the select, right? But we're working on the sales table, right? What are the conditions? The condition will be the beer should be the bar, right? Sales dot beer equals to bar, right? And sales dot price less than $3, right? Between them should be the end, right? We want to find out all the data tuples, which sell the bar beer and the price is less than $3. This will return all the data tuples, right? Covering all the attributes. What will be the next step? Will be to get the bar names, right? Sales bar for less than $3. We can represent this one as S4, right? Equals to what? Equals to pi, right? We're working on S3 here. Pi what? It should be the bar, right? Because inside we want to get the bars, right? How about the next step? Remember here we have this either or, right? We want to find out the name of all the bars which are either on the Tennessee Street or see the bar for less than $3. We may need to use a union, right? I don't know. Then let's write down the number like X here to get all the bar names, all the names of bars. Meeting our requirements. How can we represent this? We can use union, right? We can define this one as S5 or S6 equals to what? Equals to this S2 union, right? Let me borrow the union from the previous pages. Union S4, right? Can we do it in this way? Remember we mentioned, right, when we do the union, we have a requirement. For the two input relations, it should have the same schema. What is the schema for S2? S2 will be a table with one single attribute, right? The attribute name is name, right? How about S4? We get S4 by doing the project bar from S3, right? Bar is the attribute name in the sales table. So we can see S2 has a different schema versus S4, right? Even though the physical meaning of these attributes are same, they are all the bar names. However, the attribute name is different. Here we use the name, here we use the bar. Therefore, before this step, we need to do the renaming, right? We can represent the renaming as rename S4 as bars name, right? We can denote this one as S5 equals to what? Renaming. We can use the renaming. We can pull the row, right? We're working on this S4. What will be the new relation we can get? We denote this one as bars, right? We want to rename the sales bar to the bar's name, right? Therefore, we have to use the renaming to help us. And we can get the S5. Then here we can get the final result, get all the names meeting our requirements, and S6 equals to what? S2 union S5, right? So this will be the sequence of assignments. We can get all the bar names which are either on a tennis street or sealed bar for necessary donors. And we can represent the same expression as well, and we can also show this one as one single expression with multiple operators, which can be denoted as what? We can work on this one by one, right? We know it's equal to S, right? We can replace this S2 as what? As pi S1, right? What is S1? We can further replace this one with this select on the bars, right? Then we can further work on the S5. We can replace S5 as a row on S4, right? What is S4? We do the projection, right, on S3. What is S3? We can further replace S3 with this select, right? Therefore, this will be the same expression as with the one showed before, right? In one single expression with multiple operators. Okay, this is the example. Besides this two, we can also represent it as a tree, right? With the same expression, we can represent it as a tree, as shown in the slides. So given two relations, the bars and the cells, we can do the select first, address equals to tendency, and then do the projection, right? It will be similar for the sales table. We can do the selection first and do the projection. Here we need to do a renaming, right? Change the schema to be consistent at the bars, right? And then we can further use a union to join them union them together. And this will be the output for this example. I hope you have the correct answer on your papers. And also be careful when you write very long expressions. Think about it. What we want to get, and also be careful when if the schema are inconsistent, right? We need to use the renaming to help us.